Hey there, ladies and gentlemen. It's Mrs. Matheson. We're going to be doing Unit 7, Notes 5 today, and we're going to be covering tangents. All right, so we're going to use properties of tangents, and we're going to solve problems using circumscribed polygons. Remember, circumscribed means they're on the outside. All right, so let's talk about what is a tangent. A tangent is a line that intersects a circle at exactly one point. All right, only one point though. The point of tangency is actually that point of intersection. So if we look at our picture to the right, A is the point of tangency. It's that one point where our line AB touches circle C. And then we have common tangents. Common tangents are going to be things that touch multiple circles, but still touches each circle in only one place. So for example, line L touches F there, and circle G there. And then here, line L touches F and circle G at the same place. So let's do a few examples where we draw a common tangent. If no common tangents exist, write N8, not applicable. All right, so if we look here, I can start off by drawing a common tangent on the bottom. It's going to touch both circles in only one place. We have another common tangent here. It's actually going to be at this line. Oh, pretend that got real close. And there we go. All right, so looking at B, it looks like there's going to be no common tangents, possibly because they're not close enough. But remember this first one we looked at here on the previous slide, those circles weren't close either. So we're going to have a common tangent going this way, touches here and here. We'll also have another common tangent going the other way, there and there. And we can even have common tangents similar to the ones in A, which are on the outside, like those. All right, I want you guys to go ahead and find the common tangents for C and then figure out how many are there. Okay, so let's talk about our first theorem here. It says in a plane, a straight or a line is tangent to a circle if and only if it's perpendicular to a radius drawn at the point of tangency. So remember, point of tangency is that one point where they intersect. Okay, and so if my radius is perpendicular to that point, then we know that it's a tangent. So let's write that out for this picture. Line L is tangent to circle S if and only if, remember 2Fs means and only if, L is perpendicular to line ST. So perpendicular is going to use some triangles. So number 2 says, is KL a tangent to circle J? So notice we have some lengths here, and we need to figure out if this is a right angle here. So determining if it's a right angle, what theorem is going to help us with that? Yeah, it's going to be Pythagorean theorem. So using our picture here, notice that this 9 actually only goes from here to here. So this distance inside is also going to be that 8 because it's a radius. So this whole side here is going to give us 17. And that is what we are going to see as our hypotenuse. So our two legs are 8 and 15. And we want to know if those squared equal 17 squared. All right, 8 squared is going to get us 64. 15 squared gives us 225. And 17 squared gives us 289. If we take 64 and 225 and add them, we get 289, which equals 289. So yes, KL is going to be a tangent. Okay, so in number 3, it asks us, is GH tangent to circle F? Okay, notice here now that 12 is going to go the whole distance of H and F. So 6 is a side, 8 is a side, and 12 will be our hypotenuse. 6 squared is 36. We know 8 squared is 64. And 12 squared gives us 144. So if we add 36 and 64, we get 100. And we know that 100 is not equal to 144. So no, this is not a tangent. All right, find the value of x. Assume that the segments appear to be tangent are tangent. So in these problems here, it's saying it is tangent. Assume that it's tangent, so put a right angle in there. And you got to find x. Okay, so let's set it up just like our previous problems. So we're going to do x squared plus 12 squared. And, ooh, this side is going to be, we have an x and an 8, so this could be x plus 8 squared. Remember, squared means times itself, so we are thinking x plus 8 times x plus 8. Okay, so we get x squared plus 144 equals, if we go ahead and FOIL or box method this, we should have x squared plus 16x, because I combine my two middle terms, plus 64. Now in this problem, my x squareds are going to cancel out on both sides. So I can subtract 64, and we get 80 equals 16x. Take 80 and divide it by 16, and we find x to equal 5. Okay, I want you to go ahead and do B. A was definitely the more difficult problem between A and B. So go ahead and do B. Set it up again using Pythagorean theorem and solve for our x. Okay, so we have our next theorem. If two segments from the same exterior point are tangent to a circle, then they are congruent. So if we look here, they have the same exterior point of B, and they both just touch our circle in one point. That makes these two lines congruent. So we are going to just sum this up and say if AB and CD are both tangent, tangent to circle D, then AB is congruent to not CD, CB. Ooh, sorry about that. Congruent to CB. So if AB and CB are both tangent to circle D, implying that they only touch in one spot, then we know that those two are congruent. Okay. 5 says if AB and CB are tangent to circle D, find the value of x. Very simple. Those are congruent. X plus 15 equals 2x minus 5. Let's go ahead and subtract our x and add our 5. So 20 equals x. Not too difficult. Go ahead and do up problem 6 for us. And then don't forget to take your Schoology quiz, and we're going to talk about those circumscribed polygons when we meet together in class. We'll see you then.